Hi, welcome to Benchmark 2, Lesson 2. Today we're going to start our lessons on refraction. We just finished up a lab on reflection, and so now we're going to take a look at another behavior of light. Reflection is when light or any wave bounces off a surface, but sometimes waves can pass through objects, and when they do, sometimes the speed of the wave changes and it causes the wave to bend. Refraction is the bending of light waves. So take a look at page 117 or look it up online and write down what it looks like when light beams are refracted. If you're watching this video, go ahead and pause, do the warm-up, and resume the video once you've done that. For today's introduction, we're actually going to use an online resource to take notes. If you're in the slides, you can find the link to the online notes here. The notes look like this, and you're going to want to click on this link to get to the physics tutorial on refraction in the Ray model of light. So the way the notes work is that it'll tell you which part of the online tutorial to go to. There's a question and a place for you to type your answer. These are guided notes, and this won't be turned in, but it will help you to have a better understanding of refraction before I start my workshop today. So let's do the first one together. Lesson 1 is called boundary behavior. It says, what is the definition of refraction? Copy it down from the website. So you can see under lesson 1, boundary behavior. And you are going to look through the text and see what happens when a wave passes through a medium. Okay, so you'll find the information, copy it, and paste it into the notes. All right, so there's the definition of refraction. Copy and paste. That's it. So when you're done with the notes, you can come back to the slides and we'll continue today's workshop. So I'm using this slide today in class to talk about some different examples when refraction occurs. Many of you have seen a prism before, and a prism is a triangular or pyramid-shaped piece of glass that can actually take a beam of white light and bend it in such a way that all the colors of the rainbow are visible. This is due in part to the fact that each color of the rainbow has a different wavelength of light and is bent slightly different so that you can see the entire. If you have multiple prisms, you can actually set a beam of light up so that it goes in, spreads out, and then passes through another prism back as a white beam of light, which is pretty cool. This is a block of glass that shows a dramatic bending of light, and you can see that it enters. When it passes through the glass, it bends, and it bends because the light is actually slowing down. The speed of light is 300 million meters per second in a vacuum. When light passes through different objects like glass or water, the speed is dramatically slowed down. But you can see that when it exits the block of glass, it goes back to the speed at which it was traveling before it went through the glass. Okay, here's a real life example. You've probably seen fish in a pond before or any other object. If you've ever tried to dive for different toys in the bottom of a pool, sometimes where the object looks is actually different from where it is once you get under the water. This is because of refraction. The light is bending and making us think that the fish is here when it's actually slightly in front of it. So if you go bow fishing or you're trying to cast your bait in a specific spot, you need to know about refraction. This is a pretty cool demonstration. This is a tank of water with a liquid, and it's got some sort of a bluing agent to cloud it so that the laser is visible. This is a really powerful laser. We don't have anything like this in class, but you can see the bending of light in the tank of water. Another everyday example, if you've ever put anything in a cup of water, the pencil looks broken. It's just a trick of your eyes. It's because of refraction. The pencil's not actually broken. So refraction causes things to appear in a location where they're not, and this is due to the fact that light rays can slow down or speed up when they enter a new medium. The light ray bends when the speed changes. Okay, so different mediums can cause more or less bending, and we're going to take a look at that in a Phet Lab today. What I want you to remember is that no matter what, light never goes faster than 300 meters per second. That's the fastest. So here's a diagram from your book. If you want to look at it more carefully or up close, it's on page 118. And this is just a beam of light passing through several media. So you can see, I just want to point out air is here and at the bottom. So notice that these lines are parallel because the speed is the same. So it slows down in water and it slows down in glass. Now, if you look at water and glass together, which one would you guess is a medium that makes light slow down the most, water or glass? Take a second and think about that. Pause the video if you need to. So glass actually bends the light more, and we're going to get into talking about angles again. You can see that it's bent at more of an angle. So glass actually has a greater, what we're going to call index of refraction. So it bends the light even more. So we're going to do this Phet Lab today. This is a guided lab, and we will be doing this in class together and writing things together on the board. If you're home, this Phet Lab really is done best printed out. There's a lot of things that you have to draw. There's really not a good way to do this lab online. Let's take a look at the Phet Lab together. Okay, so we are going to use the intro lab. All right, if you want to play with the other ones, be my guest, but we're going to use this one right here. And let me go back to my Google Drive. I can show you what the Phet Lab looks like if you need to print it out at home. I will link the PDF for those who need it. Okay. So it's called Bending Light Lab. And this is what students will be using in class. So there are some places you can type, but once you get to the end, we are going to be drawing light bending in different media. So we will be doing this together in class. This is a graded activity, and it is our first of 2 labs for refraction. The second lab is the Jello lab, and if you have time at the end of class today, you can get a copy of the Jello lab and make your predictions of how you think light will bend when it passes through a dish of Jello. So we're going to experiment with that medium. If you have any questions about anything, feel free to email me, and when we meet again tomorrow, we will be doing the Jello lab together.